Everyone, I'm Swati and welcome back to my series on mechanics. Right now we are learning vectors and today's video is all about product of vectors and we'll do some introductory thing on scalar product. So last week I couldn't post video on Wednesday and Thursday because I was not well and so I'll try to compensate that lectures in this week. I'll try. So let's begin with that. And this topic is really important. The scalar product, the vector product. How do vectors have this multiplication rule? The algebra multiplication rule and the vector multiplication rule is quite different. So we are going to learn that how scalar vector, scalar. If two scalar, the product of two scalars, it's simple multiplication. The product of scalar vector, the product of vector vector. So all those things we are going to cover in this video. And I hope you all are practicing. And if you have any doubt or anything, any query, any question, anything, you can comment below. And if there are enough queries and questions and stuff, I will come up with a video on Saturday or on Sunday, basically on weekend, and I will clear all your doubts, all your things, whichever there in my comment box. Okay, so you can comment below and I will help you out. Rest, I come up with my videos from Monday to Thursday. Right now we are doing vectors and we'll move forward to mechanics, kinematics, and all those mechanic stuff. Okay, so let's begin with scalar product today. So today's topic is multiplication rule. Let's take multiplication rule. Okay, now just understand the concept from the very beginning. If you multiply two scalars, you know the product thing. It's simply like 3 into 2. Okay, where you can use that, let's say you have a mass of this and you put more 2 times of mass, you can simply multiply. Let's say you have a mass of 3 kg in a box and you double it, then it's simply 3 into 2, 6. Very easy. Okay, the next is, first is multiplication of a scalar with a vector. Okay, if you multiply a scalar with a vector, let's consider lambda be any scalar. Okay, it's a variable. You can take any number. Let's say lambda be 1, 2, 3 or anything, -1, -2, anything, and a vector be any vector. Now this a vector has components in x, y, z direction, that is axi cap plus ay j cap plus az k cap. In the last video I have explained you resolution, so this can also be written as a cos theta I cap plus a sin theta j cap, or a cos alpha I cap plus a sin beta j cap, or a cos gamma k cap. You can revise that in our previous video, but it can be written like that. But I have used this ax, ay and az. Okay, where ax can be written as a cos theta and ay can be written as a sin theta when theta is any angle between a vector and x-axis or horizontal axis. And you can also write it as ax is equals to a cos gamma, ay is equals to a cos beta, and az is equals to a cos gamma. Okay, where alpha, beta, and gamma are the angles between a vector and x, y, and z axis respectively. When the A vector makes an angle of alpha, beta, and gamma with x-axis, y-axis, and z-axis. Okay, so it's like that. Now, if you have to multiply this lambda with a vector, it's very easy. You have to multiply this scalar quantity with each component of a vector. That means lambda is multiplied with ax, ay, and az. Okay, you have to multiply this with everything. It's like that. Okay, now if you want to get its magnitude, you can simply under root its coefficients. Okay, and you will get its magnitude. Or you can get its magnitude and then multiply by lambda. Okay, so here's the thing, that lambda times of a vector magnitude is equals to, you get the magnitude and then multiply by the scalar quantity. You'll get the same thing. We can look at an example. Let's say your a vector is 2i cap minus j cap plus k cap. You have to find let's say 2a vector magnitude and 2 times of this. So first you have to multiply 2 with each component of a vector, that is 2 to the 4i cap minus 2j cap plus 2k cap, and then get its magnitude. So it would be 4 4 is 16 plus, always use the sign in the square, like it's minus 2 square, it's like that. So eventually you get positive outside. So it's 2 to the 4 plus 4. So this gives you 4 plus 16 plus 24 under root of 24. Okay. Now just and under root of 24 can be written as 24 is 4 6 24, so it can be read 2 root 6. Okay, so if you take 2 in the under root, it's 4 4 6 are 24. Now what we can do, first we take the magnitude and then multiply by 2. So the magnitude of a vector is what? 2 to the 4 plus 1, which is under root of 6, and then if you multiply by 2 vector, what you get? 2 root 6. So it's one and the same thing. It's not a difference. Again, if you have to calculate something like a vector is I cap minus j cap and b vector is 2i cap plus 3j cap minus 4k cap, and you have to find a minus b magnitude and let's say 2a vector minus 3b vector magnitude, then you have to multiply a by 2, b by 3, and then now in that case 2 and 3 are different, so you can't take that out. You have to multiply, you have to get this value, then this value, then you have to subtract and then get its magnitude. But if it is something like this, then you can simply a minus b, take 2 out, you can simply calculate a minus b, then you can calculate its magnitude and then you can multiply by 2. You'll get the same answer. But in this case, it is 2 and 3b. So you have to multiply separately, then subtract, and then get its magnitude. Okay. So it is something like, I'm simply getting to a vector minus 3b vector, that is 2i cap minus 2j cap. And then you have to take minus and take everything in the bracket. So you can get this minus out. Then it is 3 2 is a 6i cap plus 3 is a 9j cap minus 3 4 is a 12k cap. You have to take this minus out and multiply everything by minus. Okay, so there is a reversal of sign. That's the basic maths. Then it is minus 4i cap minus 11j cap plus 12k cap, and then you can take its magnitude. Let's take it as a c vector something, and then you can get its magnitude. That is minus 4 square is 16, 11 square is 121, 12 square is 144. Yeah. So you can solve it and you can get its magnitude. Okay, so just remember that it's very easy. And so I can tell you one more property, that if it lambda times of a vector plus b vector, or lambda times of a vector plus lambda times of b vector, it's one and the same thing. Okay, then there is one more thing. Let's say there are two vectors, two scalars. You have to multiply two scalars. So you can multiply both at a time and then multiply it with vector, or you can multiply one with vector and then other. Again, it's the same thing. It's basic logic. For example, if it is like 3 into 2, so what you can do is, let's say m is 3, n is 2, then you can do like simply 3 into 2 and then you can multiply by a vector, that is 6 into a vector. Or first you can multiply 2a vector, and means you can multiply 2 with each component of a vector and then 3. You will get the same. Eventually, it's basic understanding. Okay, so that is the multiplication thing. And if you are multiplying 0, let's say the quantity gets 0, something you are doing which eventually turns to 0, like for example in displacement, you start from an initial point and you move to a certain distance and come back to that initial point, then it's 0. So if you multiply that 0, you'll get a 0 vector. Okay, so if you multiply a 0 scalar to a vector, then you'll get a 0 vector. Okay, something like that. So that is a very basic understanding. If you multiply a scalar with a vector, again, an important thing is, if you multiply a scalar with a vector, you'll get a vector. Okay. Always. So that is something you can remember. Now, scalar, scalar vector we have done. The second thing is vector. Scalar with a vector. Now, second is vector with a vector. Vector with a vector. So if you multiply two vectors together, let's say a vector multiplied, have a product with another vector, let's say b vector. So you get two things here. First is you can get a scalar, and second you can get a vector. And on that basis, you have two different things. First is scalar product or dot product. Okay, that means your a vector, and because its name is dot, you have to put a dot here, because the b vector gives you a c, another thing, which is a scalar. Okay, so in this you'll get a scalar on a multiplication on a product of two vectors. That is why it is called a scalar product. And the second is your vector product, in which you get a vector, or you can say a cross product. Because it is a cross, so you have to put a cross here. That is a vector cross b vector, and you get a vector here. That is why it is called a vector product. So in the vector product, the result is a vector, and a scalar product, the result is a scalar. It is also called a dot product because the notation is dot, and it is called a cross product because the notation is cross. So there are two different types of product based on two different types of result. Okay, so in this lecture we are going to learn about the scalar product, and in this week we are going to cover the scalar and vector product completely. Okay, so let's understand scalar product, scalar or dot product. Okay, so I have already told you that a scalar or dot product is written as, let's say you have two vectors. Let's consider two vector, a vector and B vector. Now, if you have to do it short product, you have to put a dot here in the middle, B vector, and you get a C, which is a scalar. For example, work. Work is basically the dot product of force into displacement. Force dot displacement. So force and displacement are both vectors. They are both vectors, and their dot products give me work, which is scalar. Okay. So now, if you have to remember it like graphically or diagram say, then you can understand it like this. Let's say you have this A vector here. Okay. You have this B vector here. This is your A vector and this is your B vector, and there is some angle theta here. Now what you will do, let's take the projection of B vector on A vector. Drop a perpendicular here like we have discussed in a previous video, and along theta you can dissolve it as B vector cos theta. Now you can multiply this with this, so your A vector dot B vector is basically what? A is there and you project the other along that. Okay, if there is some angle, then it eventually becomes what? A magnitude, B magnitude, and cos theta. So A dot B can also be written as A B cos theta. That's most important formula. Okay, the theta is the angle between A and B. Okay, you have to remember that. Now, it's very easy if you say that A is here and B is here. Both are along same. Okay, that means your theta is 0 degree. So simply A dot B gives you what? AB, magnitude of AB, because cos 0 degree is 1. So it's simply AB. So you have to multiply A into B. Okay, and if there is some angle, if there is some angle there, if A is there, B is here, and there's some angle theta here, then you have to put the theta, whatever the theta is, value of theta. Let's say theta to be 60 degree. Then you have to put the value of theta here, which is AB cos 60 degree, and cos 60 is half, then it becomes AB by 2. So now you can see that how the product of vectors, algebra of vectors changes because of this angle. Can somebody tell me how I can remove this blue boxes and red boxes in the comment? Okay, so because of this direction, things changes. Next, if it is 90 degree, it's simply 0. We will understand that in cases, but it's like that. A is there, B is there. And if angle is 90 degree, then simply A dot B is equals to 0. Why? Because cos theta is 0. A, B, cos 90 degree, cos 90 is 0. So it's simply 0. Okay. Now you can see, let's say you have some A vector of 2i cap plus 3j cap plus 4k cap, and B vector something like I cap plus j cap, and theta is 60 degree here. Okay, so one method to solve this A dot B here is you simply get the magnitude of A, magnitude of B, and put cos 60 degree. And there is one more method, we will learn that later. But for this A vector dot B vector, which is magnitude of A, B, cos theta, you simply have to calculate magnitude of A, which is 4 plus 9 plus 16, and it gives you 29. And then you have, okay, this gives me the solution. A. Then 1 plus 1, 1 square plus 1 square, that is 2, 2. And then simply A dot B gives you what? Root 29, root 2, cos 60 degree, cos 60 degree is half. And you can take it as combine, that is 2 9s are 18, 1 over 2 is 58. by 2. Okay, it's like that. Next, you can also be given as that the magnitude of A is, let's say, 5 units. Magnitude of B vector is like 4 units, and find A dot B. And theta is like 30 degree. So simply, if they are given the magnitudes, so it's simply 5 into 4 into cos 30 degree, which is root 3 by 2. So it's root 3 into 5 4s are 20 by, 5 4s are 20 by 2, which is 10 root 3. Okay. So it is like this. And now you can say, if you have to calculate cos theta, then you can simply find A dot B over magnitude of A over magnitude of B. But how to find this A dot B? We'll understand. थोड़ी सी देर में. Okay. Now, there are some cases. Let's understand those cases. First is, if A vector dot B vector is equals to A B cos theta. Okay. Wait, now take it as a general term. We have learned that A vector dot B vector gives me what? AB cos theta. Now there are three cases here. First is, if theta is 0 degree, then A dot B vector is equals to what? Magnitude of A, magnitude of B, cos 0 degree is 1. It is simply AB. Now, if I take both the vectors to be same, it's a sub cases. If you have like, this is 1. Now, let's take it, say, you have A vector dot A vector. Okay, both are same. So it's simply, the angle should be 90 degree, means it is a compulsion. If both vectors are same, means somehow you are taking the same vectors, then theta should be 0 degree. Why? Because if they are same vectors, they should be parallel to each other. They're equal. This is A vector, this should be A vector. The direction should be same. So if the direction is same, then theta should be 0 degree. And then your A dot A can be written as magnitude of A, that is magnitude of A square. So if you have two same vectors, you can simply square the magnitude. So now with that, if I take its unit vector, let's say I dot I, what I need to do, I cap, magnitude of I cap cos 0 degree, because I and I are same. Magnitude of I is 1 because they are unit vectors, and 1 into 1 and cos 1 is also 1, then it is 1. That means j cap dot j cap also gives me 1, and k cap dot k cap also gives me 1. So this I dot I, j dot j, k dot k, everything gives me what? 1. Again, something to remember. Fine. Next is, if theta is 90 degree. If theta is 90 degree, then your A dot B is equals to A B cos 90 degree, and cos 90 is 0, then it is 0. Okay. Now two equal vectors cannot be perpendicular to each other. So it cannot be like A dot A cos 90 degree, obviously. But with that, if I use I dot J, because I is along x-axis and J is along y-axis, so they are perpendicular to each other, then what it gives me 0, because, the magnitude of I cap, magnitude of j cap, cos 90 degree, obviously I and j are perpendicular to each other. That gives me what? 0. That means j dot k also gives me 0. That means k dot I also gives me 0. That means I dot j, j dot k, k dot I, everything gives me 0. Again, something to remember. Okay. And using these two things, if I have to calculate this A vector dot B vector component wise, so what will I get? Let's say A can be written as AXI cap, AY J cap plus AZ K cap dot product of BXI cap, BY J cap plus BZ K cap. Just multiply this by everything. So you'll get AX, BX, which are the scalars, you can make it out, and I cap dot I cap because they are the vectors. Then plus it's simply the distributive property I cap dot j cap. But what I'm doing, I'm taking the scalars out and combining the vectors, the unit vectors I j k cap. Then plus AX BZ I dot K, then plus AY with everything AY BX J dot I plus AY BY J dot J plus AY BZ J dot K plus AZ BX K dot I plus AZ BY K dot J plus AZ BZ K dot K. Now, as per our result, this I dot J goes to 0, I dot K is also 0, J dot I is 0, J dot K is 0, K dot I is 0, 0. So the things which remain is I dot I, which is 1, J dot J is 1, K dot K is 1. So if I dot I is 1, so what you get simply AX, BX, not J dot J is also 1. So you will get what? AY, BY, K dot K is 1. You will get AZ, BZ. So interestingly, for A dot B, what you have to do, you have to multiply its component together, the same component together, the X component plus Y component plus Z component. Very convenient. For example, if you have A vector to be like 2I cap plus 3J cap plus 4K cap, and your B vector is I cap minus J cap. So for the product, dot product A dot B, you have simply multiply the I components together, the J components together, and K components together. So it's 2I cap plus 3J cap plus 4K cap dot product of I cap minus J cap. So multiply this I components together. This is 2, this is 1. So you'll get 2 into 1 is 2. You don't have to put I cap, J cap, simply plus. Then it's plus 3I cap minus 1 gives you minus 3. This is plus 4, there is no K, that means you have 0 K cap here. So you'll get 0 here. So it gives you 2 minus 3, that is equals to minus 1. It could be negative, okay? So it is like this. So now, in this case, if you want to calculate cos theta, what is the angle between this? You have given only these two vectors. And you have to calculate cos theta. So it is simply A dot B divided by its magnitude. Okay. So what you have to do? You have to calculate its magnitude and divide minus 1 by that. So magnitude of A is what? 2, 3, 4. 2 to the 2 square is 4, 3 square is 9, 4 square is 16. You get 29. And for B vector, you get I cap minus J cap, that is 1 plus 1, that is root 2. So cos theta can simply be what? A dot B is minus 1, put minus 1, magnitude of A is 29, this is root 2, so it's minus 1 over 2 9s 18, 1 over 58. It is like this. Okay, this comes out to be different, but it is like this only. It is cos inverse minus 1 by root 58. That is the angle between these two vectors. Okay, so this is the basic thing which we have learned today. One, this important formula, A dot B is magnitude of A over magnitude of B. Then this thing, A dot B can be written as AX, BX, AY, BY, AZ, BZ. Okay. And then I dot J, J dot A is 0, but I dot I, J dot J, K dot K is 1. A dot B can be written as AB cos theta, where one is a projection on other. And you have two types of product, vector and scalar vector. Oh, sorry. Scalar product is dot product, vector product is cross product, and scalar vector is very easy. So this is all for today's video. In the next video, we'll learn some more properties on scalar products. We'll see more examples and we'll do some more numericals on scalar product. So thank you for watching this video, and please do comment all your queries and questions. I really want to help you out. Whatever I can do for you, I will do. So feel free, comment below, just paste or copy anything, your query, any topic or any numerical, any concepts, whatever you facing that problem, you can comment below and I will help you out on Saturday. Okay, we'll come with that video, but you have to put that comments in the week so I can prepare a video for Saturday. Okay, so thank you again so much for watching this video, and stay tuned with me, and we'll learn together. Okay, so do like, share, and subscribe. Share with your fellow mates who are in class 11 or who want to learn vectors or mechanics. And see, vectors is something which can be used in mechanics and electrodynamics. It's a very important tool, so you can learn that. So stay tuned with me. We're going to do many more numericals on this topic to deepen or strengthen this particular topic, and then we'll move to mechanics. Okay, so again, thank you so much, and we'll meet you tomorrow.